Hello guys, this video I'm going to explain to you what is the insertion, the insertion sort algorithm about. So just before we start on diving in how it works, I have to tell you that this algorithm, better works with arrays of a small size, a small size arrays. So it is good for these cases. But if you had a bigger size, array, I do not recommend using this algorithm. You can use match sort instead. So if you happen to have a big size array, I recommend using another algorithm. So it's wrong for big size arrays. That's it. So now that you have these three in mind, I'm going to explain to you just 2 points you have to keep in mind as well. So first, we work from left, We work from left to right. That's the main point. And then you have to take in mind that when we have an item, we compare that item to all of the left items, to all of the left neighbors of that item. Okay, just remember those points. So imagine that we have this array. So imagine we have this array A33, 1, 4, 22, and 2. So as the points I put out here, we work from left to right. So we shall start here, from left to right. Now we compare the item to all of the left items. And in this case, as this is the first item, we don't have items to the left, so we mark this as sorted. And then we start with 33. 33 we compare with 8. That's the only neighbor that is in the left. So we compare. We see that 33 is greater than 8, so it is in correct order. We don't swap it, so this is ordered. Then we have a 1. We compare 1 to 33. 33 is greater than 1. So we swap both of these. So you take all of the array, and then you put the items in place. But it doesn't stop there, because it says that we compare to all of the items, all of the left items. So we have already compared to the 33, and then we have to compare it to the 8. So that's how we put 1 first. So we know that 1 is less than 8, so we have to put this first. And now we can say that this is sorted. And then use do the same to the rest of the items. So 4 compares to 33, and then if it's greater, if it's less, then it swaps. And then you compare 4 to 8, and then 4 to 1. So it obviously 4 is less than these two, but it's greater than 1. So when we compare 4 to 1, it doesn't swap. So it's gonna be 1, 4, 8, 33. That's it. It works the same with the rest. It works the same with the rest. 22 in this case is less than this, but it's greater than all of the rest, so it's gonna stay here. So we just copied it. 22, 33, and the last item is 2. So we compare 2 with all of the left neighbors until we find it that the left neighbor is not it's not greater than 2. So in this case, 2 is gonna be next to the 1, of course. And that's how the insertion sort algorithm works. Right now we can say that this array is correctly sorted. So as you can see, this algorithm, the most items you have in an array, like the most amount of time it will take, it will handle it worst. So that's why I believe that if you can use this algorithm, please use it with a small amount of items inside of an array. All right. So that's it, guys. And the next video I'm going to implement this insertion sort algorithm on different languages. But if you understand the idea, you can just program it on every language you like to do it. All right. That's it, guys. Thank you very much for watching.